Let's talk a little bit now about reflections of graphs. So to talk about reflections of graphs, I want to use one of my favorite, easiest to transform graphs, which you should all recognize as y equals the square root of x. A reflection is shown algebraically by negative signs. So let's see, I have the square root of x on top graphed here in purple. If I wanted to turn that off and instead show you what happens when there's a negative applied to the outside of the graph, here's what happens. The graph gets reflected around the x-axis. The reason it gets reflected around the x-axis is because the negative on the outside of the function, so in front of the function, changes all of our positive y's to negative, and if we had any, negative y's back to positive. So a negative applied to the outside of a function reflects your graph around the x-axis. On the other hand, if there's a negative next to the x, that's going to change the sign of the x values, meaning positive x's become negative and negative x's become positive. So if I took the square root of x and multiplied the x by itself by a negative, it would reflect around the y-axis. So to summarize, a negative on the outside of the function reflects f of x about the x-axis, but a negative on the inside next to the x reflects f of x about the y-axis. Let's try just two quick examples that practice this. So to start, let's sketch y equals negative absolute value of x. Now remember, you know already that the absolute value of x is our v graph. And this negative that we have here for our reflection is on the outside of our function. So it's going to reflect about the x-axis. It's going to reflect on the other side of the x-axis. So in purple, we'll do the reflection about the x-axis. Cool. So the yellow one was just the absolute value of x, and the purple one is the one that we're looking for, negative absolute value of x. For example 2, let's do a similar function. Let's do, for example 2, let's do y equals the absolute value of negative x plus 3. So I'm kind of working in a reflection and a horizontal shift in here. It's really important that you do these in alphabetical order, like I said in the previous video. So we're going to do first horizontal shifts. Second, we're going to do reflections. And third, we're going to do any vertical shifts. So since this plus 3 in here is a horizontal shift, and remember it moves this opposite of what it looks like to the left 3 units, we're going to take our fabulous absolute value graph, which I won't regraph because it's right here, and we're going to move it to the left 3 units. So 1, 2, 3, we're at negative 3. And there's our graph. So that is the absolute value of x plus 3 without the reflection being done. And then the negative x, this is next to the x. So this should reflect this about the y-axis. So our graph will look in the end, I'll do this in green. I want to reflect about the y-axis. So a lot of times you'll see people draw that little arrow I drew, reflecting about the y-axis. So 1, 2, 3. So a mirror reflection on the other side would be for this graph. So I took all, reflecting around the y-axis, all my negative x's become positive, and any positive x's that we had become negative. Finally, let's discuss stretches of graphs. So you should all recognize this graph. This is y equals x squared. This is our parabola opening up.
And if we were to do a stretch on this graph, it would be in the form of multiplying the function by a constant. So I have two possibilities here. We're going to first multiply by a 5 and then by a 1/10. So notice what happens when we multiply the function x squared by a 5. That function got narrower. The graph of the function got narrower. However, when we multiply the graph by a 1/10, the function by a 1/10, it's still a parabola. It still opens up. It just gets wider. So stretches of functions can be seen algebraically by constant coefficients in front, multiplied in front to our functions, in front of our functions. However, they don't shift our graph in any way, up, down, left, right. They don't reflect it. They just affect the narrowness or the wideness of the graph. Me being a math person, I am uncomfortable with vague words like narrow and wide. How wide is wide enough? So this is the only time in this section that I would suggest plotting one, maybe two x values, besides something simplistic like 0, just to see precisely how wide or how narrow the 5 or the 1/10 or whatever you have does affect your graph.
All right, now for the fun. We're going to do a few examples that put all of these transformations together. And keep in mind, we need to do these in alphabetical order. So we're going to do first horizontal shifts, then reflections, then stretches, then vertical shifts. Now, to be really honest, a couple of these can be moved around, but I think that alphabetical order is really easy to remember. So what is actually crucial is that you do your horizontal shifts before you do reflections, and you do reflections before you do vertical shifts. That's what's really important. So let's do a couple of examples. Okay, to get started, let's sketch y equals negative absolute value of x minus 3. Okay, so what we have here is the negative is a reflection, and it is a reflection, okay, this negative was on the outside of the function. That's changing the y values, so it's going to be a reflection about the x-axis because it's on the outside. And the minus 3 is on the outside of the function, so this is going to be a shift, a vertical shift, down 3. And we don't have any horizontal shifts, and we don't have any stretches here. So if you remember that the square root of x is the rainbow one, then I'll draw this one in black because it's our parent graph. Should look like that. And let's see, according to this list, alphabetical order means we don't have a horizontal shift. We should do the reflection first. So reflecting this about the x-axis, let's make this one yellow. Oh, I'm sorry, let's make this one red. So this would be the negative only in square root x. And then down 3 from there, I'll do that in purple, taking that red graph and moving it down 3. Sorry, I can't draw very well. I have negative square root x and then minus 3. Okay, let's try another one. Let's try y equals 1 over negative x plus 1. Okay, so let's take a look at where everything is here. Looks like we have a negative next to an x, so that would be a reflection. And we have this plus 1, and the question you need to ask yourself is it inside the function or outside of the function? Well, this minus 3 was clearly outside of the square root, making it a vertical shift. The plus 1 is inside the fraction, so that would be a horizontal shift. So we are going to move left 1, that's our horizontal shift, and we're going to, that negative is right there next to the x, so that will reflect, let's see, the right next to the x changes the x values, so it's going to reflect it around the y-axis. Reflects about the y-axis. Okay, so according to our steps, we have to do our horizontal shift first. So I'll do the parent graph in black. That's our hyperbola. Oh, that's an ugly one. Let me redraw that. There we go. Okay. And we need to do the horizontal shift first. So we need to go left 1 unit. So I'll do that in red. So shifting everything left 1 unit, that's going to move the vertical asymptote, but not the horizontal one. What a messy graph I'm going to have. Okay, and then we need to reflect it about the y-axis. So reflecting about the y-axis is going to be a reflection like this, left and right. To make it easier to see, I'm going to, you know what? I'm going to graph that next door. How about we just graph it over here? So reflecting this about the y-axis would move it over here. So reflecting this about the y-axis would move this asymptote reflected to the other side at +1. And what else? This would move over here. The lower left would move to the lower right. And that would look like this. So this red curve on the lower left moves to the lower right. So it would look like this. And up here in the upper portion, the red gets reflected around, so it would look like this. Cool. Okay, let's try one more up here at the top. Let's go to blue. And let's graph y equals -5 times the square root of x plus 2. Okay. Again, we have our fabulous square root function here. That's the rainbow function, half the rainbow. And we have three things happening to it, actually. We have the +2 is going to be a horizontal shift, so that will move it to the left 2. That's a horizontal shift. The negative is on the outside of the function, so this reflects it just like the first example about the x-axis. And the 5 is a stretch. Okay, so that means that we're going to plot some points. So let's get started. So I'm not going to graph the square root of x because it's just right here. We're just going to move that graph to the left 2 units. So that will look, I think I'll do that in green. Moving it to the left 2 units would look like this. Okay, then I want to take this, let's see, what comes next again? Reflections. Okay, so we're going to reflect about the x-axis. So here's the x-axis. We're going to reflect it about the x-axis. So it's going to now turn this direction. That's an ugly graph. Let me try that again. Glad you couldn't see that. There we go. Okay, so now the graph is flipped as a reflection around the x-axis. Now to do this stretch, this is what I would do. To do a stretch, you would pick an x value that would make this easy to calculate. You want to be careful of anything that gives you 0 because that's the one point you do have already. So I'm not going to pick x equals -2 because -2 plus 2 gives me 0, and I already know that it goes through -2, 0. But if x, let's say, were, I don't know, how about 2? Then I would have the square root of 2 plus 2 is 4. I don't even need a calculator for that. So for the stretch, instead of worrying about the 5 as a number bigger, so it's going to make it narrow and wide, and what does that look like for a square root, let's plug in x equals 2 simply because it's easy to calculate. 2 plus 2, and we're going to plot 1 point. So I have this negative 5 times the square root of 2 plus 2, which is 4, which is negative 10. 5 times the square root of 4 is 5 times 2, so y equals negative 10. So way down here at negative 10 would be x equals 2. So I would have a stretch that would look like that. Cool. For our last couple problems, let's return to these from our homework where we're not given the equation. And if you remember in the previous video, we have already done A, B, and what else? Oh yeah, D. So now I'd like to do the other 4 for us. Okay, so let's start with C. Let's do this one. Great. So C gives us a brand new letter, capital P equals negative f of x. And if you remember from your reflection section, this was a reflection. Let's see, it changed this negative to be specific. It changes our y values. So if it's changing y's from positive to negative and negative to positive, that's a reflection around the x-axis. So this is a reflection about the x-axis. Okay, so we'll take our pivot points again, just like we did in the last video, and reflect them around the x-axis. There's my little around circle. Well, the silly thing about, I don't want to use blue on blue. Let's do red. The silly thing about reflecting something around the x-axis that's already on the x-axis is it's not going to change. So let's look at this point down here. So negative 3 pi and negative 6 is going to be reflected around the x-axis. So it'll come up here, and it'll be at negative 3 pi and positive 6. And positive 3 pi and positive 6 will be reflected around the x-axis, and will come down here. So what we'll have instead of the blue graph is its reflection in red, negative f of x, a reflection around the x-axis. To do part E, because we did D in the previous video, to do part E, we have q of x equals 1/2 of f of x. Now remember, this was a sort of stretch, and what I recommended for these stretches was to plot some points. So what I want you to notice is this is multiplying 1/2 by the y value, or by the f of x value. So in other words, if we're, let's say here at y equals 6, 1/2 times 6 would be 3, and that would be down here. The x value is not going to change at all. 1/2 times negative 6 would be negative 3. And the rest of the points, 1/2 times 0 is 0. 1/2 times 0 is 0. 1/2 times 0 is 0. So this graph in green is our graph of q of x is 1/2 times f of x. So it's a stretch. Actually, these stretches that stretch down, these are called compressions. Okay, so when you have, when I told you in the previous couple of frames to plot points and you don't have any points, I should give you some sort of y value here, and this is how you can plot the points for these. Okay, let's do, oh, that's not D. I called it D. That was E, wasn't it? Okay, let's do g of x equals little f of the quantity negative x. Now, we've discussed reflections, and this reflection with the negative is right next to the x's, so it's changing the sign of the x's. So it's making positive x's negative and negative x's positive. So that's a reflection back and forth about the y-axis. So we have, what color have I not used? Let's do yellow. We have here a reflection about the y-axis. Now, I am convinced that this is going to lead to one of the things that people get confused on when we do especially reflections and stretches. So we're reflecting about the y-axis. So everything on the right side of the y-axis moves to the left, reflects to the left, and everything on the left reflects to the right. So if we were to do that, this pivot point, let's do this pivot point up here because it's easy to see at 3 pi comma 6 moves to negative 3 pi comma 6. The pivot point at positive 6 pi moves to negative 6 pi. And likewise, the pivot point at negative 6 pi moves to positive 6 pi. Oh, good. Then this pivot point here at negative 3 pi negative 6 moves to the other side. So what we get, whoops, try to draw that better. There we go, is this. So that graph, this is an interesting graph here. This is a graph, this f of x we have is called an odd function. We've talked about those. And odd functions, when you plug a negative in for x, you get the same thing as the negative f of x. So if you notice, when we reflect it around the x-axis graphically, we got this red graph up here for part C. It's the same graph as we got when we reflected around the y-axis. That's just a unique aspect of these odd functions. And I think that's one of the things that confuses people with reflections is sometimes you can do a completely different reflection and you get the same answer. So this one in yellow ended up where it did because we technically reflected around the y-axis. It's a coincidence of the function that it's equivalent to reflecting about the x-axis. Okay, last one, let's do G. Okay, for the last one, we have h of x equals f of 2x. And we didn't spend very much time on this in the slides. This is a horizontal stretch or compression compared to the 1/2 f of x. And it's worth doing. There's one or two in your homework. But what this is going to do is this is going to compress our graph horizontally by a factor of 2. In other words, if we take the x's, remember how in the previous one we took the y's and we multiplied by 1/2? In this case, we take the x's and we divide by 2. So we would have, at this x value being at 6 pi, we would have 6 pi divided by 2 is 3 pi. So this point here would move in. The point here that was at 3 pi would be at 3 pi over 2, so 1/2 pi, about here. 0 divided by 2 is still 0. And then negative 3 pi over 2 is negative 1/2 pi, so that's about here. And let's see, negative 6 pi divided by 2 is negative 3 pi, so that gets moved into here. So what we have is, oh, I graphed one of those incorrectly. This one, at negative 3 pi halves, that should be here. So here's our smushed in version in purple of the horizontal compression. On your test, this is the one part, it's in your homework. I'm not going to test you on horizontal compressions. There are better ways to do them when you get to the classes that you need them for. But all the rest of them you will be tested on. I just wanted to show you how you smush them in, for lack of a better word, horizontally when you have a 2x. All right, for our grand finale problem here, let's sketch, this guy, right. Call him little f of x. Let's sketch capital G of x is negative little f of the quantity x plus 1 and then plus 3. Okay, let's get started. Okay, remember we always want to start with horizontal shifts first. So that would be the plus 1 on the inside, and I'll just call it h for short, and it's going to move the graph to the left 1 unit. So we'll take all of our pivot points, move them to the left 1 unit. And we're going to go connect the dots and with the parabola. Okay, next thing, we do any reflections. So the reflections would be the negative out front. And remember, the negative out front, that's going to change the y values. So if we're changing positive y's to negative and negative y's to positive, that's a back and forth reflection around the x-axis. So it's a reflection about the x-axis. So about the x-axis. Okay, so all of our positive y's become negative. So this point up here, I'll start here, at positive 5 is going to get flipped down to be at negative 5. The point here at x is 0 and y is 1 is going to get flipped down to be y is negative 1. I'm only looking at the red graph right now. When x is negative 2 and y is positive 1, it's going to be x is negative 2 and y is negative 1. And then finally, when x is, where are we, negative 6, and y is negative 3, it's going to be flipped up to x is negative 6 and y is positive 3. Okay, so it was line on the left, so a line from x is negative 6 to x is negative 2, going down. Horizontal line from x is negative 2 to x is 0. And then this parabola portion is going to be flipped down, and it goes down from 0, negative 1, down to x is 1, y is negative 5. Okay, there's our green graph right there with the horizontal shift and then the reflection. And then finally, we finish off with our, we don't have any stretches. Yay. But we finish off with our vertical shift. And that would be the plus 3. It's going to move it, it's the vertical one, it's going to move it up 3. So taking our green graph and moving everybody up, I'll start on the left. We'll go 1, 2, 3, 1, 2, 3, 1, 2, 3, and then finally 1, 2, 3. You think I was shifting? No, I'm good. We're good. We're going to go down and over and partial parabola. Cool. So that lovely purple graph is g of x equals negative f of the quantity x plus 1 plus 3.